Here's test video number 1 with my new setup. Don't have my clip-on mic yet, ordered the wrong thing. Hopefully the audio isn't too terrible. We'll see how it goes. But it's a good time to test it out because we're going to skip over chapter 1, mostly because there's not that much into it, so I'm just going to very quickly breeze through the few things it does talk about. And there will be a little optional assignment at the end, which I'll mention here in just a second. But if you would like to start the semester off on the right foot with a nice, easy assignment, I would recommend hunting down and finding that chapter 1 rigor, is what I call the chapter assignments, and getting that done sometime within the next week or so. It's pretty easy, like I said. First thing that chapter 1 kind of introduces us to is just the book itself. We will primarily use the physical textbook when we're here in class, but if you're not, then rather than checking out books or making everyone lug around the textbook, I just use the online textbook. It works pretty well and actually has some extra benefits, which I'll also get into in a moment. But to access that online textbook, there's a spot on Google Classroom already where there's a link to take you to here. You'll see that chemistry has a spot for an access code. When you hit that link, the physics textbook will have that as well. Mine's gone because I'm already signed in. So the first time you log into it, you will need the access code that goes along with it. That's also on Google Classroom in a few different places. There's a spot that just says access the textbook, and I think every single rigor that I post will also have the link and the access code, just to make sure you have that code whenever you need it. But copy that big ugly code, paste it into the access box, make sure you're pasting it into the physics book. It will not work for the chemistry, and that wouldn't help you anyway. Now, when it comes to navigating the book, it's pretty convenient, although their wording choice is a bit strange. Make use of the jump function. You can just type in whatever page number you want to go to, click jump, and then it'll jump you to that page. So now on to the science. Chapter 1 is just an introduction to physics in a general sense. So if you do access the book, which if you're watching this video, I do recommend, go ahead, maybe pause, go access the online textbook, paste that code in, and follow along with me here. And I would go to page 4, so type in 4 and jump to page 4. What is physics about? Good news is, it's really only about 2 things. It just so happens that those 2 things are pretty big things. First thing is matter, the stuff is made out of. Anything and everything that you can touch, see, or hear. I said see, there's one little exception, arguably, but for the most part, everything in the physical universe is made of matter, teeny tiny little particles. The other thing that physics talks about is energy, which is what's behind every single action that ever occurs in the universe. It's kind of the fuel that allows things to happen. You gotta spend energy to make stuff happen. When you put those 2 things together, that's kind of everything in the universe. So it is fair to say physics is about 2 things. It so happens that those 2 things make up everything, outside of stuff like philosophy, I suppose. If you want a more in-depth answer that delves into those a little bit more, check out page 6, 7, and 9. This book does a pretty good job of summarizing those important details. But I'm going to jump to this next question. Is physics the most complex science? And that word complex is the key there. For something to be complex, it needs to have many moving parts, or a lot going on about it. So with that in mind, I just said that physics is only about 2 things. 2 things is not very much. So I would say, and most textbooks would say, that no, physics is not the most complex science. In fact, it's sort of the opposite. It's the simplest, because it breaks everything down into the simplest forms. You can kind of think of the system of science like this. We start with physics, That's the simplest science, all about particles moving through space. If you get enough of those particles moving through space at a time, then you start forming elements and compounds, and you get into chemistry. Chemistry, while some people find it easier than physics, it is technically more complex because there's more stuff going on at one time. Then if you get enough chemistry, enough chemicals going on at one time, then you start forming living organisms, and then you're back into biology, which you've already taken and passed. That's one of the more complicated sciences, because physics talks about a ball rolling down a hill. Chemistry might be talking about two elements rolling down a hill, then colliding and forming a new compound. And then biology, you got a whole rabbit made up of tons of different chemicals running through a field to go find some food, which that is a much more complex system than just a ball rolling down a hill. Now, another question you could ask, is physics the truest science? And by true, that's kind of a complicated word. True meaning we can test things, we can verify our hypothesis, and get good, solid evidence either for our hypothesis or get good, solid evidence that disproves our hypothesis. And one of the main reasons physics is my favorite of the main sciences is because it is the truest science in that respect. It's the easiest to actually run tests. So if you want a good explanation about what science means in general, go to page 11 and 12 and skim through that, or better yet, read it fully. Now we've got to talk about some limitations though. Physics, although it is great and arguably kind of simple and very true, it does have its limitations. One I've already mentioned, philosophy.
Teachers, please excuse this interruption.
Try to edit that out maybe, we'll see. One of them is philosophy. Physics doesn't really help us out with that. Anything to do with morality, that's beyond the scope of the real physical world. That gets real complicated once you start getting into psychology and things like that. Human brains are very, very complex. But let's say we form a hypothesis, which, as you've heard before, is kind of like an educated guess, but generally a very educated guess. You have an idea about something and you have hopefully good reasoning for why you think that. But it is still something that you can test to hopefully figure out if it seems to be true, or test and figure out that it is definitely not true. Turns out it's much easier to prove things aren't true than it is to prove that they are true, but we may get into that later. Scientific theories, on the other hand, are a little bit of a step above. I would say anybody can have a hypothesis. We are all scientists. And by we, I mean humans. Every single human being is a scientist because we all, from childhood, test things out. We try to figure out how things work, and that's what it means to be a scientist. But for something to become a scientific theory, it's got to have a lot of evidence pointing towards the direction of your hypothesis being correct. But it is still just a theory, technically, like gravity. Gravity is a theory because we can't prove it completely. It just so happens that over the course of hundreds of years, every single time we test gravity, it seems to work the same way in every case. So, theories are pretty strong. If you can ever disprove a scientific theory, you come up with a clever experiment to disprove a scientific theory, do that, write it all down, and get famous for it. Because that's a big deal if you can disprove a scientific theory. Now, we do sometimes hear people give science a little bit of a hard time. And that just boils down to people not using the word theory right. Really, back in the day, before we misused the word theory too much, we didn't need to say scientific theory. We just said theory. Theory meant a hypothesis that had a lot of strong evidence behind it. But then over time, people misuse the word theory over and over and over again, so much so that the English language kind of just shrugs and adapts to accept this new way of using the word theory. Nowadays, when people say theory, they oftentimes just mean a guess, without any real scientific evidence to support it. But words are important, and it's really good to keep the meanings that they used to have, because when words lose their meaning, historically speaking, bad things tend to happen. So really, we should just say theory, but for the sake of clarity, we'll stick with saying scientific theory. Plus, tacking on that scientific just makes it sound cooler. Now, research, when it comes to research, another reason physics is the truest is because it's the easiest to research, because it's simple. Once you start dealing with chemicals, there's so much going on that even if you run a test out a hypothesis, you still can get evidence to support your idea, but there's just so many variables changing and morphing at all times, it just gets a little muddy. That's not to say chemistry research is nonsense or not worth doing. It's just a little bit more difficult, generally speaking, than doing research in physics. In physics, it's easier to find solid evidence, either supporting your hypothesis or disproving your hypothesis. Because it's easier to control what's going on with a physics experiment, because there's only a couple things happening at once, and through some clever engineering, we can usually hold certain tidbits constant. Chemistry, you got a bunch of chemicals, liquids in jars, then mixing and sloshing together. It's hard to really control too much going on there. You can do it. That's not to say you can't, but it's just more difficult. Definitely when you get into biology, it's real hard to keep things under control when you've got living organisms running around, interacting in all kinds of different ways. Now, the book we use is called Essential Physics, and I really love this book. This was not the book that I had when I was a high school physics student, unfortunately. I don't remember the title of the book that I had, but it wasn't great. This one, though, I really like. For a few reasons. So if you're following along, maybe jump over to page 13. That's where I'm kind of getting some of this stuff. One reason I like it is it puts a lot of emphasis on if-then logic, keeping things, again, simple. If this happens, then what? If I do this, what's going to happen then? And there's usually a very clear line of cause and effect. The reason I think it's good to focus on that goes beyond just physics. The kinds of skills that we get from studying physics and practicing various things carry over to everyday life. Even if you never do physics again in your future, once you get out of this class, you'll hopefully still be using if-then logic in just your daily decision making. Always be thinking through, if I do this, what's the outcome? What are the positives? What are the negatives? That way you can make educated decisions. Cause and effect, hypothesis, kind of the same thing. Before making any sort of action, try to think, if I do this, what are the outcomes? Are they good? Are they bad? Should I do this? Maybe, maybe not. Think it through though. And this book and physics in general really emphasizes having accurate communication. What I mean by that is saying exactly what you mean. One thing you may notice as time goes on in this class is I put a lot of focus on trying to make sure I'm communicating accurately. I would not say that I'm a good communicator because it doesn't come naturally to me. I'm not a people person, and sometimes when I get to talking, my mouth tries to move a little faster than my brain is able to keep up. So if I'm teaching and I pause, it seems like a weirdly long pause. I'm just trying to think and pick my words carefully so that when I speak, the words that come out are exactly what I meant to say. The meaning that I'm trying to convey comes out as clearly and concisely as possible. It's not to say I'm always great at that, but I try, and I think everyone should try. The world could avoid so many issues if everyone would take the time to say exactly what they mean. Now, one way this will show up in our physics work is when it comes to writing things down, showing a certain amount of work so that we could pass our paper off to a different person or a different, we'll say, research lab. And they can see what we did so that they can recreate exactly what we did. See if they get the same results. If they do, good. Maybe our experiment was good and productive. If they do the exact same steps and get different results, then we really need to analyze what happened and figure out how that was possible. So, not just clarity, that's where I fall short sometimes. That's like talking smoothly, not stumbling over words, talking at a good, clear volume, which those things are good and we should strive for them. I certainly try, but more important than that is accurate. Oh wait, there's one. So if you flip over to page 25 through 26, we get into other ways that being a good physicist kind of helps you out in just the regular world beyond physics. One of them is evaluating promotional claims. A good physicist is really good at those. What I mean by that is, let's say you're scrolling on some social media and then an ad pops up. For whatever reason, you decide to actually watch it instead of scrolling past it. You get a lot of promotions or people trying to sell you things and making it sound way better than it actually is. There's a phrase called snake oil, someone trying to sell you snake oil, because way back when there were people that would gather, I guess, venom and then sell it as various medicines that could cure all ailments. And they made it sound really good. They were super charismatic and they did make sales, even though what they were selling didn't actually do anything. It was too good to be true, that kind of thing. Skills we get in physics kind of help us identify too good to be true, or if we see that there's a gap in the reasoning, then that's a clear sign that something's not right here. We can also see the trees and the forest. Sometimes you hear a phrase something like, can't see the trees for the forest, because some people focus too much on the big picture and fail to pay attention to the details. And then on the flip side, some people focus just on details and forget about the whole surrounding story, the whole surrounding picture, which is just as bad. Physics, since the picture is generally pretty small, it allows us to practice focusing on the details and the full picture, how they all fit together, so that we can then take that out to the real world and apply that same kind of reasoning to everyday things. I think it's maybe page 26 gets into study skills. I think studying physics has made me better at studying really just other subjects. So if you would like to know a few more study skills along those lines, I would read page 26. It's worth your time. If you struggle in this class, specifically, read page 26. It gives you some pretty good insights or suggestions. If you want to know how to succeed in life in general, you should read page 26. It gives some pretty good suggestions. But that's really all chapter 1 gets into. So at this point, if I were you, I would flip back to Google Classroom, go to classwork, find chapter 1 through 3 of that section, and then find the optional assignment for chapter 1. There's a few questions. There's not really much math at all, I don't think. So give it a shot, and you'll get a pretty good grade on it. It's fairly straightforward. And if you have any questions, feel free to post a private comment in Google Classroom. That sends an email to me, and I check my emails pretty much constantly throughout the day. Hopefully the audio is not terrible. Hopefully I'll have an actual mic in the future once we get into the real physics, starting more so in chapter 3.